Hello class. Today we're doing polynomial functions and their graphs. So you should be on the second part of your notes and we're going to talk about multiplicity, we're going to talk about intercepts, we're going to talk about where their turning points are, all different types of things. If it's even, odd, if it's symmetrical. So we got a lot going on today. I hope you have your notes out and let's go. So when you go here, we're going to identify a polynomial function. So you need to look at it and tell me if it's a polynomial and what it looks like. Characteristics of the graph, how many times does it cross the x-axis? Which direction does it start and stop at? We're going to factor it. We're going to talk about multiplicity and the intermediate value theorem, so how I tell where I have a root. We're going to look at the difference between degrees and the turning points, and we're going to graph these things. We're actually just going to sketch them. They're not going to be real graphs. Okay, you have seen this before. So this is just what a polynomial is. We've talked about it, was a little bit a while ago. So the ANs are just coefficients, and the X's are variables, and they have to go in descending order. Look at your n minus 1s, all the way down to when you have no X's. The leading coefficient is always the one attached to the first term, or the X with the highest coefficient, and the degree of the poly is always the highest exponent. I think I said leading coefficient is attached to the highest exponent here. End behavior, if this AN here is positive, that's how it ends. So if it's odd, it's going to end all right. We'll talk about this later. So this makes more sense with numbers. Here we go. Let's go down here to our pictures. Okay, my leading coefficient right here. This is starting down, ending up. So it's starting negative, ending positive. Okay, if it starts and stops opposite, it's an odd degree. So I know this is an odd degree because they are not the same. The end, so up here, how it ends is if it's a positive A or a negative A. So this is odd because it's opposite, positive because it starts there. It's probably some kind of x cubed is what we have here. A positive x cubed because it crosses 3 times. If you look at this, it goes up 1, down 2, turns again 3. So there's 1, 2, 3 sections. So I have x cubed. Now let's look here. It opposite again because it starts positive, ends negative, so I know it's odd. If you look here, let's count them. 1, 2, 3, 4, 5. So you go into your turning points. So this is probably an x to the 5th. It could be more because it could have imaginary roots, but this is the lowest it could be. It ends negative, so that means it's a negative x to the 5th. Okay, now let's look at our even graphs. We know they're even because they are going, stopping, and starting at the same point. This guy starts positive and ends positive. They're both called end behaviors, but that's okay. Let's look here. He goes 1 to a turning point, up to a turning point 2, 3, 4. So this is an x to the 4th graph, probably, and it's positive. Now look this, they both end down. How many times is it? 1, 2, 3, 4, 5, 6. So it's an x to the 6th. He ends negative, so he is a negative graph. I hope that helps. So let's go here. Let's see what we know. We have 3x to the 5th. It's positive, so I know it ends positive. It goes 5 times. So it's going to end positive, start negative because it's odd, and it's going to cross 5 times. Let's go to our curve. So we go 1, 2, 3, 4, 5. So you go 1, 2, 3, 4, 5, ending positive, starting negative. Okay, that's all you have to do. Draw it on your graph. 1, 2, 3, 4, 5, and you're done. Okay, try yours. All right, yours was even, and it's negative. So since it's even, it starts and stops the same. So this in here starts negative, it ends negative, and it crosses up to 4 times. So you should have done something like this. 1, 2, 3, 4. And you are done. You are also could have drawn it way up here. It wouldn't have mattered. All right, or down, as long as you always have it going negative and negative. Let's go here. Okay, when I talk about zeros, roots, solutions, x-intercepts, all of these they mean the exact same thing. So all four of those words mean I let it equal 0. So if I could say what the zeros are, you would do the same thing as if I asked for the roots or the solutions or the x-intercepts. Those are four words that are identical. So let's plug in 0 here. And we have x cubed plus 2x squared minus 4x minus 8. Okay, to help me out, I need to know what this thing looks like. So it's x cubed, so I know it's going to cross 3 times. It's positive, so I know it's going to end positive. So remember, it's going to start negative. So it starts negative, goes 1, 2, 3, ends positive. So now I'm looking where it crosses this x-axis. It can cross 3, 1, or 2 times. We'll find out here. So it's 4 terms. The only way we have of solving that is by grouping. Take out what they have in common. Over here we have -4. Now we have x squared minus 4, x plus 2. But the problem is this here can be factored again, right? So this is x plus 2, x minus 2, x plus 2. So that means x can equal -2, x can equal +2, and x can equal -2 again. All right, this is weird. All right, if it was 3 separate numbers, I'd have 3 of them. If 2 of the numbers, all right, so you have an even number of the same root, it is called a turning point. Whoops, point. If you have an odd number of the same root, it will pass through, all right? It will flatten, but it will pass through. So I have an even number of -2s. So I know I'm going to go to -2. So it actually counts twice, and 2 here. Since I have -2 twice, I know I start down. So I'm starting down here. I have to go up to -2 and then turn because it counts twice. It's this side of the wave, and then it's this side of the wave, see? And then it's going to go back up through 2. So this counts 1, this counts 1. Those both count at the -2. And then this guy comes back down and goes through here. Why that disappeared, I have no idea. All right. I hope that makes sense to you. Okay, let's do the next one. Well, it's kind of mean. I should have given you a different one. Okay, pause and try yours. Okay, yours is a really tiny graph. So you should have looked at x cubed. So it's positive, so you know it ends positive, starts negative, so you know it's a cube graph, looks like this. Factored it out, you got 3.5, so you went to 3.5, so 1.5, and you put a dot, right? But then when you did this time, you had a positive 1.7 and a negative 1.7. Well, the negative is not too hard to graph because that's just here, but this is so close to that 1.5. I know it starts down. It's going to cross all 3 times. So it's going to start down, go up, and then barely go over that x-axis to go back. And there's your graph. I hope you did a great job. Okay, this one here, we already did. It wasn't one on the other page, so we're just going to cross him off. That's multiplicity. Remember when we had the 2 positive 2's? Okay, I want you to pause and try yours. So you're looking for 2 of the same root, just a hint. Okay, you had 4 terms, so you knew you had a group. That's an x cubed, so again, it looks like this, ending positive, starting negative. We grouped the first 2 and the second 2, remembering are negative on the inside. So you took out your x squared, your -9. Now the x squared minus 9 factor into x plus 3 minus 3. So now you have x equals -3, x equals 1, and x equals -3. You have 2 -3's, which means -3 is a turning point. 3, you only have 1, so it passes through. All right, so the first thing we do is we start down, we go up to the -3. Since it's a turning point, we turn back around and then go back up through 3. Not too bad. Later on, we'll learn what these actual turning points truly are on the rest of the graph and graph these more accurately, but not yet. Okay, this one here is already done for you. So they've done all the factoring. And they're trying to show you what you have here. When it says how many zeros, what you do here is you add all the exponents. So we have a 2 and a 3. So we have 5 zeros. So it's going to cross the x-axis or touch 5 times, right? We look here, we set both of our factors equal to 0. So we get x plus 1/2 equals 0, which means x equals negative 1/2. And then it equals negative half however many times we have it. So we have 2 of these. So this is twice. Since we have 2, it is a turning point. Now we look at the next factor, x minus 5 equals 0. So x equals 5. We have 3 of these. So since this is odd, it passes through. It's going to flatten out. Whoop. Flatten out, but it is, I can almost write, flatten out, but it's going to go through. Okay, so turning point, negative 1/2, crosses through is the positive 5. So we go to negative 1/2 and we put our x and 5 and we go here. Okay, negative, and it's a fifth. So this is like a negative x to the 5th. So it means that it's going to start positive, 1, 2, 3, 4, 5, and negative. But this time, 3 of them are going to be in the same spot, so it's not going to quite look like that. So we're going to start high. We're going to go down to negative 1/2 and turn. Okay, that's 2. We're going to go back up, and then at 5, we're going to level out and go through. This here guy counts 3 times. So there's 3 of them there, 2 of them there, which are 5, and that's what our graph. You don't know these points right here yet. I use decimals to graph this to kind of cheat. So that should help you out. Okay, pause and try yours. First thing you should have said, it's a 4th graph, so it's x to the 4th. It's positive 3, so I know it's going to start and end positive. Okay, I have x minus 4 set equal to 0, so x equals 4, but that happens 2 times, meaning it is a turning point. X plus 3 equals 0, so x equals negative 3. It also happens 2 times, so it's even, so it is another turning point. So we go to negative 3 and we put our dot. We go to 4 and we put our dot. We know those are turning points and we know we start positive. So I go here, I turn, but then I got to go back around and hit the 4 and turn again. You don't know exactly where this is happening, but you should have the general shape there. Intermediate value theorem is just saying if I plug in 2 numbers next to each other, if they change sign, so the y value is opposite, then there's a root because it has to cross the x-axis. If the y value is not opposite, then it is not a root. So if I go here, right, let's just pretend I'm going to put in an x is 1 and an x is 2. Let's say x is 1 and y is 3, and x is 2 and y is negative 4. Well, the y values changed signs, so I had to cross the x-axis. Now, if I was here and I had 1 and 2 again, let's say y was 3 or 4, and then y was 3. Well, it didn't have to cross the x-axis because it's the same sign. That's what the intermediate value theorem is saying. So change signs, we have a root. Doesn't change signs, no root. Nothing weird, just a really long name. So I want to know there's a real 0 between negative 3 and negative 2. So all we do is we plug in negative 3 into my equation and then negative 2 into my equation. So we go 3 times your negative 3 cubed minus 10 times negative 3 plus 9. And when you plug that into your calculator, you should have gotten negative 42, I think. Okay, now let's plug in the negative 2. So we do 3 times negative 2 cubed minus 10 times negative 2 plus 9. And this time you would have gotten a 5. They have a sign change. So that means there is a root between -3 and -2. We don't know exactly where it is, but we know it crosses there. Okay, pause and try yours. So when you did f of 1, you plugged 1 in, right? 3 times 1 squared minus 2 times 1 plus 6, and you should have gotten 7. You plugged in 2 minus 2 times 2 plus 6, and you got 14. All right, no sign change means there is no root between 1 and 2. All right, we're going to use that later on to graph stuff. Okay, next one, understanding between degree and turning points. So this is a 2x. Now, if you look at this, when you graph it, it goes straight up. How many turning points does it have? And the answer should be none. Okay, 3x squared minus 8, you know that's a parabola facing up, has 1 turning point. X cubed positive, so you know this is a cubed going like so. It has 2 turning points. So what is the relation between the degree and the turning points? 1 degree, no turning points. 2 degrees, 1 turning point. 3 degree, 2 turning points. So if I have degree n, I have at most n minus 1 turning points. So there's always one less than what you start with. Okay, this is just a review. Leading coefficient test to determine the graph's end behavior. So remember, if it's positive or negative, it's how it ends and starts. It tells you both. X-intercepts, you let it equal to 0. If it has more than 1, if it's even, it's a turning point. If it's odd, it crosses through. All right. And if it's greater than 1, it flattens out, is what this is saying down here. Y-intercept, you let x equal 0. Axis of symmetry. This one here we haven't talked about yet. But if you plug in a negative x and you get the same function back, it is even. If you plug in a negative x and you get the opposite set function back, it is odd. If this happens, it's symmetrical over y, and this one here is symmetrical over the origin. All right, we don't use that a ton, but sometimes it's helpful when graphing. All right, let's see what we got. 5-step process, we'll just go through this. So first we look, we have a 2 and a 1. Remember, we add these. So this means I have an x cubed, and it's 2. So this guy is going to end positive, start negative. So it's going to look like this. It starts negative, ends positive. So we'll say it starts negative, ends positive. So that's our end behavior is what that is called. All right, next we have to find our roots. So we know we have x plus 2 equals 0. So x equals -2 2 times. So it is a turning point. We have x minus 3 equals 0. X equals 3 1 time. So it passes through. It does not flatten out because it's only 1 time. Next, we look at x-intercepts and y-intercepts. So let's do x, well, this is the x-intercepts. Let's do the y-intercept. That's where you let x equal 0. So we go f of 0 is equal to 2 times 0 plus 2 squared, 0 minus 3. All right, so this is the y-intercept, what we're finding here. So you got 2 times 2 squared times a -3. So 4 times 2 is 8 minus 3, -24. And that's not even going to fit on our graph. We'll pretend. So now we got to graph these things. So we're going to put -2 is our turning point right here. It's going to pass through 3. We know it's a cube, and we know it goes through -24. We're going to pretend that's right there. I know it starts low, ends high. So I'm going to start low. I'm going to turn at -2. I'm going to go through, -24, and back up through 3. We do not know where this point is yet. It's just a guess. But you're getting closer. We're getting more points on our graph. All right, pause and do yours. Okay, I hope you did well. You should have had 2 turning points this time at -1 and 3. You should have added the 2's up here and got 4. So we had -2x to the 4th, which means it starts negative and ends negative. Our y-intercept, we plugged in our 0, and you should have gotten a -18. Should probably write that out. Now when we graph this, we start low, because we know that's what we start. We go up to -2. We turn around. We have to go through our y-intercept, back again and turn at the 3 and come back down. All right, good luck on your homework. I hope you do well. Make sure you post stuff on the discussion board if you have questions.